Okay, welcome back. What I want to continue with now is, again, Level 3 NVQ Diploma in Installing Electrotechnical Systems. Don't need to read this through to you now. You should have seen this now many times already now, by now. Okay? Now, just make sure it can be seen, okay? And that you haven't missed anything out. And then that is easy to read. Now we're looking at session 8, and here's where we are, session 8, RCDs and discrimination, okay? Okay, let's go down a little bit, just make sure we got everything in place. Okay. And here we have learning outcomes for this session. Okay. Student will be able to gain an understanding of RCDs, gain an understanding of discrimination between RCDs. Let's make sure you can read that in full. Okay. Pan back out a bit. Yeah. Okay, and stay for us. Good. Thank you. Make sure there's nothing else. Nothing else. Thank you. Good. Okay. Now RCDs. Okay. Just making sure that it's in view and that you can it is easy to read. Okay. Just pan back a bit. You can get it all in. Okay. Now section 415 details the requirements of BS 7671 for the conditions where additional protection to that required by a specific protective measure is required. There are two means of providing additional protection. These are RCDs refer regulation group 415.1. Now be aware for any changes in regards to the 18th edition or any future changes which may occur. Okay? And supplementary equipotential bonding reference regulations group 415.2. This section will only consider the use of RCDs. Okay? Okay, you can see that, so you should be able to fully. Okay, and I've gone a bit, so get that fully in frame. Okay, good, thank you. Good. And here we have residual current device, RCD. Okay, and let me just make sure you can read this for yourselves. Okay. RCDs. Okay. Now let's just make sure we get this in frame, okay? So you can read it for yourself at your own leisure, okay? Right. Pan back a bit. Let's get it all in. Okay. Okay. Now RCDs come in all shapes and sizes. Some have time delay features. The three types are A-type. Operation is ensured for both AC and transient DC. AC-type operation is ensured for AC. These two types are both available in the ordinary type, where there is no time delay. S-type, selectable time delay, which can be used to prevent unwanted operation. The requirement for additional protection is that the RCD will have a rated residual operating current, I delta N, not exceeding 30 milliamps, and a disconnection time of not more than 40 milliseconds at a residual current of 5 times I delta N. Okay. Now I'm just going to bring the CD in first. Internal features of an RCD, and here we have the internal features of RCD. Okay. Now remember that you need to draw this diagram out for yourself so you can understand it more in depth, and do some ground research as well. Okay. Okay, let's go back a little bit and get back into focus. Okay. Bring it fully into frame. Okay. Okay, good. Got to make sure that there's nothing missing, and bring the text into play for you to read. Okay. Okay, let's go back out. Now the RCD has an iron easily magnetized core. This core is wound with a surge coil, which is connected to a trip coil. The core also has two other coils, line and neutral, wrapped around it. These are the line and neutral conductors. Okay. I'm just going to bring this down so you can see. Now here we have healthy circuit. Okay, healthy circuit. That means the circuit is not operating at this point in time. So let's go and make sure that we have full view of it in place. Okay. Okay. Panning out a bit. Okay, let's get this back in frame. Okay, and let's go into our text. Now, I want you to be able to read this for yourselves so you can see what needs to be done and how the operation is applicable. Okay. Okay. Get back into frame. Okay. Healthy circuit. Okay. Now let's go take that text. Now, in a healthy circuit, the same current flows in the line and neutral conductor. The current in each conductor produces a changing magnetic field around itself. The changing magnetic field around the conductors produces a magnetic circuit in the core. The interaction of the two magnetic fields produced by the conductors cancel each other out, and the search coil cannot sense any difference between the two. So you can see here that the search coil is looking for the difference between the live and the neutral current at any point in time, and it is continuously doing that all the time that the circuit is active and that the circuit is healthy. Okay. And you can read and see the coils for yourself. You don't even need to be pointing them out to you either. Okay, and they're well colored. Okay. Now here we have in a circuit with a fault on it to earth. Okay. Let me move into this so we can get a good picture of this. Okay, in full. Okay. Okay, good. Okay, let's go back. Okay, let me go up a bit and get it into focus now. Okay. Again, let me bring the text into play. Okay. Okay. And I'll just go back just to make sure that it is all can be read. Okay, let's go back and panning out a bit now. Okay. Just make sure we can get it all in. Okay. Okay. Now a different current flows in the live conductors. Now these magnetic fluxes produce a magnetic circuit in the core. As the two currents are different, so the magnetic fluxes are different, and the magnetic circuit in the core is not cancelled out, and the search coil picks up the difference. If the two currents are out by a set amount, then the search coil will operate a small relay that will trip a switch, opening the circuit and making it safe, thereby providing your means of isolation. Just go up, make sure we haven't left anything down. No? Okay. Okay. Now, let me just bring that down. Overloads. Okay. Then make sure you can read this for yourselves. Okay. Okay, I'll bring this back up. Let's get back into phase. Well, get back into view. Okay. Okay. Overload. Everything operates on balance. If the currents aren't the same, then the RCD will operate. If the currents are the same, then the RCD will not trip. This means that we have to be aware that an RCD will not trip under an overload condition, unless of course it is an RCBO. If there is a fault between line and neutral and the current flowing is 500 amps, then because the magnetic circuit in the core of the RCD is balanced, then it will not trip. It may well just blow. Right, installation CDs. Sorry, installation RCDs. My apologies. I'm gonna have to put my teeth back in. Now, the installation of RCDs depends on a variety of factors. These include: it must disconnect all line conductors at substantially the same time. Regulation 531.2.1. Where a circuit normally expected to have a circuit protective conductors does not have one, an RCD is not a substitute for such a fault. And again, you can see the regulation there for yourself. An RCD used for fault protection in association with an overcurrent device must be able to withstand thermal and mechanical stresses that are likely to occur. Discrimination should be achievable. And again, it tells you which regulation to look at. Regulation group 531.3, regulation group 531.4, etc. Okay, deal with specific issues associated with TN systems, TT systems, and IT systems, respectively. Where an RCD is to be used to protect against fire, then the requirements of Section 532 apply, and an RCD must not be rated greater than 300 milliamps. Okay, so let's go in and make sure we can get these in view for you to read. Okay. Okay. And here we have discrimination. Sure, I can bring this into view for you in full. Okay. Let's make this up, bring this up, okay. Now, look at your discrimination here. You have your supply, A, your main distribution boards, whether that be B or C, okay, and your load centers. Okay. This is your diagram. Well, I would call it a line diagram, and this would be your kind of block diagram to represent this circuit here. Okay. So you have means that any problem occurs here, this fuse should blow before this, and this should blow before that. Okay. That's what it's trying to tell you here. Let me just make sure I haven't missed anything out. Okay. Let me go into the text. Okay. Okay, that's good. Thank you. Okay. So discrimination, the RCDs will always have to involve time. The upstream device will have to have a time delay, as even a small current is likely to trip RCDs when they are connected in series. Okay. Now again, look at the relevant IEE regs. Look at your on-site guide. Use the information in there. Look at the examples given in your on-site guide. Use that information again and again. Okay, I hope you found this useful. Okay, that's it. That's the end for that. Okay, here. And this is the end of session 8. Okay, in regards to unit 3 or 4. Now have a good day. Bye bye for now.